distribution, and x1, x2, x3, x4 are independent observations of x, that means this. I showed you this animation before, and I think I find it super useful for us to know this. Let's say you draw from a population here, which is normally distributed. Now, if you take a look here, I'm going to pick 10. 10 randomly chosen values of x, and that is the mean of the first 10. Correct? Another 10 here, randomly chosen 10, and then I get another mean of x, the second. And I do more, and then I get another point. Now you realize very funny, right? You pick 10, and then on average, you will usually get values that are near to the mean. Actually, it's not funny, it's quite expected, right? Does it make sense? So now we want to anticipate what is this. How does this final distribution look like? Does it look similar to the original x? Let's see. If I pick 5, you will get this. Another 5, another 5, another 5, another 5, another 5, another 5. You realize that the values are all centered near the mean. Does it make sense? Now, if I don't do 5 already, let's jump straight to 10,000. You will expect to see this. You see the values here? You will see this. What it means is that if x follows a normal distribution here, x bar also follows a normal distribution with the same mean, because the mean is symmetrical about the mean, but the variance is different. The variance is different. The variance is smaller. So what we are saying in the whole thing about 4.5 is this. If you look very closely, you realize that x bar, this is the distribution of x bar. The mean is the same. The standard deviation, or rather the variance, is different. It's a bit smaller. Is that right? Ken? That's the whole thing we talk about in 4.5. So let's carry on. And you can now see that in example 3. Now turn to example 3 now. You see, we've completed example 3 on Tuesday, right? Let's make some sense of example 3. You want to find the probability that 80 people, the mean of the 80, exceeds 1.69. So it is not x greater than 1.69, it's actually probability x bar greater than 1.69. Got it? Yes? So it all boils down to this. I want to know what is the distribution of x bar, not x. For example 3, it is actually n equals to 80. Of course, this website limited don't have 80 lah. You know what I'm saying? But essentially that's the same idea. Got it? Okay, so that's that for example 3. Now let's carry on with example 4. A machine produces cylindrical rods which radar is normally distributed. So you will see radius is normally distributed with this mean, with this variance. Look, standard deviation is 0.005, so the variance is this. Two of such rods are selected. Find the probability that the sum of their radii is less than 0.994. So, sum. To solve this question, let's take a look. We will say let S be equals to R1 plus R2. Let's copy. R1 is the radius of one rod. R2 is the radius of another rod. These two are independent observations of R. Does it make sense? S is R1 plus R2. This is the first rod, this is the second rod. Both are random variables. Alright? Now, we learned earlier, recall 4.5, right? Earlier. If R is a normal distribution, because R1 is independent of traditional R. R2 is also a normal distribution. R1 plus R2 is also a normal distribution. What is the mean of R1 plus R2? It's sum. So what is the mean of R1 plus R2? So S belonging to a normal distribution, 2 times 0.5. Correct? Yes? What is the variance? Variance is it's variance. Remember, variance of this is variance of this plus variance of this. So which means variance of R1 plus variance of R2, that means 2 variance R, which is 2 times this. So I'm sure you can write this down. This is i.e. S follow a normal distribution, we mean 1.0 variance 1, 2, 3, 4 0.00005. 4 zeros, I think. Yeah, 4 zeros. Okay, R is normal. This is normal. Normal plus normal is like a sample sum. Normal plus normal will give you normal. Okay? So that's that. You press your calculator and you will get your answer. This is from GCR, not difficult. 0.19807, which is 0.1983 SF. Now let's take a look at the second part of the problem. Find the probability that the diameter of a randomly chosen rod is less than 0.994. The question here, find the probability that the diameter of a randomly chosen rod. Just now, R was the radius of a randomly chosen rod. So, in part 2, let D be the diameter. D, can I say that D is actually 2R? Yes, D is 2R. And if D is 2R, what is expected value of D? I think we know this is 2 times expected value of R, which is actually 1. What is variance of D? What is variance of D? Is it 2 times variance of R? 2 square. It's 2 square. 2 square. Whoa. Which is 0.000. Now recall, maybe I will write here, variance of AX plus B equals to A square variance X. Alright, recall. This A square, this A square. Can? Alright? So now you've got a distribution of D. I think it's not difficult to press a calculator very quickly and get this answer. Okay, come. Let's practice pressing your calculator and check whether do you expect the part 1 answer. Is it the same as part 1? Come. Come, press. Practice. Get some answer. Answer to part 1 was 0.198. Now, in part 1, we are talking about one rod rod 1 and another rod. I use different color. And then add them up. In part 2, what we are talking about is I have rod 1 and then I times 2. Does it make sense? Yes? Oh, there is a difference. Do you get the answer? Who wants to shout out the answer before I randomly choose one? It's quite fun. I want to show off my Excel file. Come, shout out to save your friends. 0 point? No? Do it lah. Or you want me to do it? Oh. Okay, quite fun lah. Okay, come. No, this one try only. Just, no, wait, relax. 3, 2, 1, go. Where's Edwin? Wait, don't act blur lah. Come lah. Where's Edwin? Not here. Here not? Not here, really not here. Okay. 3, 2, 1, go. Eugene. Come, answer quick. Come, answer leh. Quick. Eugene, come. Wait. I never do. I give you a clue. It's 0 point something. You got answer, all of you got answer? Managed to get answer? Different for part 1, right? Different for part 1. 0.840. Do you get 0.840? No lah, cannot be 0.8. You see, now, one way to, okay, let's say for example, not just Eugene, all of us, you got 0.840. Now, you should actually think whether your answer is logical or not. You see, your mean is 1. Correct? Your mean is 1. You want to find probability, the D mean is 1, D less than 0.994. Now, one is here, it's 0.5, it's 0.5. Area is 0.5, 0.5. Your 0.994 is here. So you're going to find this area. You'll never get 0.8. You will get something less than 0.5. Okay, another person. Ian. Where? It's Ian, yes. Ayo. Need help 0.425. You get 0.425? Do you know why you get 0.425? I think because you key in this as your standard deviation. This is actually the variance. So, answer 274. This is the variance. Okay? Or this is the variance. In key, you must square root that value. Or by convention, it's always this. This is variance. All right. Let's come back to the more important question now. The key is simple. Part 1. We are talking about pick one rod, measure, you got a radius. Pick another rod, you got a radius, you measure. So it's actually R1 plus R2. Part 2, we are talking about one radius multiplied by 2. So, the mean is the same, but the variance are different. Why? You would expect the first variance, this one R1 plus R2, to have a smaller variance because whenever you pick 2 at random, the 2 will average itself out. The chance of getting an extreme value is lower in a way. You'll get some idea? Alright, so it's different. Alright. So how do we make the distinction? Now this is important now. What is the difference between x1 plus x2 and 2x? Now you can say, example, x is the weight of one melon. The total weight of two randomly chosen melons is x1 plus x2. Is x1 plus x2. Because I'm talking about two melons here, I randomly choose one, and I pick another one, and I add them together. Whereas, the weight of twice the weight of one randomly chosen melon is then 2x. There is a difference. Just like what we talked about earlier, the radius of one plus radius of another versus the radius of 1 times 2, which is the diameter.